Hello, I'm Rebecca Barnes and welcome to the Science ESA Vodcast. In this episode, our voyage through the solar system brings us to two of the terrestrial planets, Venus and Mars. We will explore their similarities and differences to Earth and find out about the European missions that are helping to unravel their mysteries. Before spacecraft were launched to explore the solar system, there was much speculation about the nature of Earth's closest planetary neighbours, Venus and Mars. Venus, with its shroud of thick clouds that obscure the surface from optical telescopes, was thought to be covered with water and lush rainforests. Dark patches observed on the surface of Mars were thought to be old seabeds filled with vegetation. Venus, Earth and Mars are grouped closely together in the inner solar system. These three planets have much in common, such as their rocky composition and geological features, and they are the only terrestrial planets that possess atmospheres. By understanding our closest planetary neighbours, we can learn more about the evolution of our home planet. Venus, Earth and Mars were all made from silicate rocks and varying amounts of volatile elements when the solar system was forming. The big question is, what happened to make them evolve into the very different worlds that we see today? Venus is our nearest planetary neighbour and Earth's near twin in mass and radius. Despite these similarities, the more than 30 spacecraft that have explored Venus have yielded surprising discoveries and a most inhospitable planet.
As Venus orbits the Sun, it rotates in the opposite direction with respect to the other planets, and extremely slowly, just once in 243 Earth days. This is even longer than a Venusian year. Unlike the slow rotation of the planet, the top of the Venusian atmosphere whips around in just 4 days. Most of the atmosphere around Venus consists of carbon dioxide. Incredibly, Venus and Earth have about the same amount of carbon dioxide. On Earth, it is locked up in the crust in the form of carbonates. On Venus, it mostly exists as gas. Sulfur dioxide is also present in the atmosphere and through chemical reactions with water vapor forms sulfuric acid droplets. These droplets develop into complex, thick, swirling clouds that form noxious fog and acid rain on the surface of Venus. The dense atmosphere exerts a pressure that is 90 times greater than the atmospheric pressure on Earth. With no protective magnetic field around the planet, the solar wind strips gas from the atmosphere of Venus out into space. This has a huge effect on the climate of the planet. Venus is the hottest planet in the solar system, with a surface temperature of over 700 Kelvin, despite only a small fraction of the light it receives from the Sun reaching the surface. The large amount of carbon dioxide and other gases trap enough energy to increase the temperature dramatically, causing an enhanced greenhouse effect. Such a high surface temperature led scientists to quickly dismiss ideas of present-day oceans of liquid water and life on Venus. The age of a planet's surface is generally determined by the number of craters present. In the case of Venus, only the largest rocks would be able to survive the journey through the thick atmosphere. Therefore, Venus has very few craters on its surface, and none that are older than about 500 million years. At some point in the past, over a short geological time period, the entire planet was flooded with lava.
Mars formed about 4.5 billion years ago, at the same time as the Earth and Venus. The plethora of spacecraft that have visited Mars since the 1960s have discovered a dry, barren and dusty red world.
Mars has a thin atmosphere that rotates with the planet. Despite being about 100 times less dense than Earth's, the atmosphere is dense enough to support a weather system. The Martian wind causes some of the most spectacular weather on Mars, from tornado-like dust devils to huge dust storms that can last for months and engulf the entire planet. Carbon dioxide dominates the Martian atmosphere, which contains small amounts of other gases, including water vapor. Particles of frozen carbon dioxide can condense high in the atmosphere, creating thin clouds. Water ice also causes clouds to form, along with lower-level haze and fog. Before the space age, the Martian surface was not believed to have many prominent features. Spacecraft images have shown that, on the contrary, Mars has many spectacular geological features. These include a huge canyon known as Valles Marineris that is so long it would stretch from the Atlantic to the Ural mountain range, and the largest volcano in the solar system, Olympus Mons. This huge volcano is nearly 3 times higher than Mount Everest. Olympus Mons lies on the edge of another large feature on Mars called the Tharsis Dome. It is on the Tharsis Dome that all the largest volcanoes on Mars are found. The dome is a huge bulge on the surface of Mars that rises to a height of about 10 kilometers. The southern and northern hemispheres of Mars are distinctly different. The entire crust of the southern hemisphere is extremely old, with rocks that were formed about 4 billion years ago. This old surface is littered with craters and is where the mountainous rocky highlands are found. The northern hemisphere is much smoother, and there are far fewer craters, indicating that the surface is much younger. The surface of Mars is riddled with scars, formed sometime in the past when liquid water flowed on the surface. Channels, valleys, and deposits of sedimentary rocks all provide strong evidence for this.
The first spacecraft to visit Venus and Mars completely changed humankind's view of Earth's planetary neighbours. Scientists now realise their similarities as well as their differences to Earth. Greater knowledge of Mars and Venus has spurred continued exploration with even more advanced spacecraft. Exploring a hostile world like Venus is challenging. Spacecraft that have landed on the surface have quickly succumbed to the intense heat, extreme atmospheric pressure, and burning acid rain. Attempting to probe the atmosphere in visible wavelengths alone is futile, as the clouds cannot be penetrated and show no features or markings. Therefore, other wavelengths of light must be used. In 2005, the European Space Agency launched its first mission to explore Venus, and the first to go there for more than 10 years. Venus Express made a 5-month journey from Earth to study the planet from orbit. This spacecraft is packed with a suite of instruments to study the Venusian atmosphere and near-space environment at radio, visible, and infrared wavelengths, performing spectroscopy and measuring energetic particles. Data from Venus Express allows scientists to study how the workings of the atmosphere, the atmospheric loss to space, and the greenhouse effect all act together to produce a climate so different from Earth. Venus Express primarily examines the planet's atmosphere. However, the atmosphere is so dense and therefore closely associated with the surface that studying it will provide clues to the nature of the planet as a whole.